So one thing that occurred to me at CSS Day is that, okay, we have all these demos and it's about standards and upcoming things, but I also like to write CSS that way, like for in my free time. But what I saw on the screen was not how the CSS was really used in my code base. Like in my code base, we use React and we use CSS modules. Even in my side projects, I would use Svelte, and Svelte has its own way to namespace styles. So the two main ways I write CSS these days are not really covered in CSS Day, which seemed like an odd omission. And over the years, I've written CSS in many different ways. When I had an agency, I did a project with Tailwind, for example, and then there was a project where I had to convert stylus into the regular SCSS, so that's not regular CSS. So basically, there's a lot of different ways to write CSS, and the way that's covered by the conference is only, let's say, the vanilla way of writing CSS, which is fine. I think tutorials and most documentation should be in vanilla and trying to explain the standard to people without like going into an abstraction. Personally, I hate it when I see a tutorial, for example, that uses Tailwind, because you are teaching a JavaScript tutorial that shows Tailwind, because you are making it more complex for other people to understand by adding an unnecessary abstraction layered on top of what you're actually trying to explain. In code examples, there is this thing called a reduced example, where people want to debug something, they want a reduced piece of code so they can actually focus on the problem at hand and to not have enough dependencies. And when teaching someone how to write CSS, for example, it's nice to not have too many dependencies. However, given this point, I still had the feeling that we are kind of ignoring how the CSS is written in the real world, let's say most of the time. There's a lot of people doing different ways of CSS. CSS modules is actually quite popular for web apps, and there are other ways to do things. There are people using web components, but not so much. Most of the websites, statistically, in the world are WordPress websites. They might not even have a real way to write CSS, but just put Elementor things together. But from a most daily perspective, I would say that most people are either working for an agency and they have the freedom to write marketing CSS in a CMS kind of way, or they work for a web application context where they have their own stack, and their specific stack, which is connected to the frameworks. They are most likely using a Vue framework like Angular, Svelte, Ember, React. There's more Vue, and depending on how they set it up, they have a different way of writing CSS. And what occurred to me in a lot of the examples of last year was that we saw a lot of examples where authors were trying to stretch CSS to its limits. They were trying to use new features, most notably the has selector, to see if they could count things, put some more logic in CSS. People were trying to make CSS like a kind of computational engine. And I get it. I understand why you would want to do that. I understand why you want to stretch the limits of CSS, either for creative reasons, like Sana showed us last year, or just for practical reasons, like you don't always have control over the other parts of whatever is being computed. But I still could not help to point out and think about, okay, what can you pre-compute? A lot of new CSS, like container queries, like has, it is self-referential. It is like you're writing a piece of code, but it's actually about another piece of code. So you have to be very careful that at runtime, there's an orchestration of the right pieces of code and they all work together. And we saw that with container queries. Like container queries had a super hard time getting developed because basically it was going to cause an infinite loop. And last year it was explained by, well, this year, but I'm making this recording in the perspective that it's going to be last year. We saw Miriam Suzanne explain how those queries, they unblocked that problem of the infinite loop by creating this moment in time where data is fixed, where an element, a DOM element, is effectively contained. And that is a good solution. That is an interesting solution. It finally unblocked container queries, but it does add complexity to the rendering loop. So we have to be careful, I think, in some ways that we are making things not too complex. Another example, I talked to the author of Project Wallace, and he said, like, okay, I have a problem here. I'm trying to create an abstract syntax tree of CSS, and he basically has a specificity graph, a complexity graph, and what Project Wallace is it's a statistical analyzer of your CSS code. So the CSS code, you put your CSS through the analyzer, and then you see a specificity graph, you see a complexity graph. But some of the newer selector, like is and where and has, they don't really have a specificity. Or you have the CSS layers. They add specificity, but in their own way. Like they kind of are a construct on top of the regular specificity. So as an author of a statistical analyzer of CSS, he now has, with all those new features that Una talked about in her talk last year, a massive amount of new CSS features, then he has a new problem. Like, how do I even parse that? How do I even make a graph that shows the complexity of the CSS? So as a language, things are getting more complex, and the complexity is sometimes needed, but I often had the feeling, and this was kind of the base of my talk and my thoughts, that a lot of the complexity maybe belonged in other parts of the system. Like, for example, the pagination example where somebody hides the 11th item with CSS and counts the amount of items with a complex CSS selector logic with 50 lines of CSS to try and get the value of the amount of items, the amount of pagination items inside of your CSS. Whereas that data, it's actually already there. If you put an index in your template engine, whatever you're using, here's an example, you already know. And like we have done for a long time, you can then put a class, for example, and then with that class you can then put border none, whatever you're trying to do, or display none on the last child, or do something with the first child. And it's cool that you can do things with CSS, and there are ways that it's useful to do things with CSS. You don't always want to write a specific template code just to solve an issue. For example, grid, it's wonderful. Your CSS is independent of your markup in a lot of ways, whereas if you write flexbox-based code, you kind of have to write wrapper diffs if you're going in multiple axes. If you're coding in multiple axes, it might be easier to do that than dealing with CSS grid, but basically you are creating a series of boxes that is a family that is defined by how they flow, left, right, a wrapper that goes left again. So you're basically recreating an auto layout kind of logic within your CSS code. All approaches have their benefits, and all approaches have their downsides. And another example that was talked about is custom properties. So custom properties, there is it's very popular, right? And rightfully so. You can natively in the browser set a variable-like construct, and you can say, okay, I want this color and I want to reuse it. I want this font family and I can reuse it. And if you change, for example, to dark mode on your system, bam, everything changes with it. Like no need to refresh the page. It just works whenever an outside property changes. So that is very cool. And theoretically, you can do a lot of those things also with SAS and SCSS and other preprocessors, but to many people, those have been feeling like dated for a long time. They need to install it as a dependency. It's not lightweight at all. Sometimes you may be messing with like a Ruby versions or Node packages just to get it done, to get it in your build system. And maybe there is these kind of local bugs. And as a dependency, it is quite a heavy one. And people have maybe rightfully tried to avoid it for some projects. But I still think that SCSS or SAS or just anything that can pre-compute something can be worthwhile and a worthwhile consideration to add to a system. Because basically what is going on is that because of what I mentioned before, the self-referentialness, the complexity of some of the modern CSS, is that you're putting a lot of stuff in your code that maybe is not needed at runtime, and maybe you're loading bits and bytes that are actually never used. Imagine if you have a color system with 100 colors, and now you're gonna load. You're in reality, that's the marketing color system. That's what's happening in our company. That's the marketing color system. Those colors are there, but in reality, in the UI, we are only using about 14 of those colors. So I want, yes, the documentation of the 100 colors, but I don't want to actually use them. In SAS, it's no problem. You define the 100 variables. You only reference 14, and then at compile time, your 14 values are translated, or your 14 variables are translated into values, and bam, you don't have any overhead. But if you have 100 custom properties, you are shipping those 86 unused variables to the client without really using them, and that's maybe it's only 10 kilobytes or 15 kilobytes of selectors, or even less, but it's still overhead that you don't need, that you're shipping to the client, that people have to load. And the thing with all these little changes is that you might get your system to be slow, as in by 1,000 cuts, dead by 1,000 cuts, or it's slow by 1,000 cuts. What it means is that, for example, we talked about selector performance last year, and Patrick Brosset, he basically said, you are very unlikely to have CSS selector performance problems. And that is probably mostly true. But then 1 minute later, he pointed out, okay, there is this website that has a lot of CSS selector performance problems, even making it that it takes a long time to render. So what is it? How can we solve it? So these problems, they do occur if you have a complex DOM, if you have complex CSS layered on top of each other, you will get into the realm of performance problems. And what I want to say is that maybe not everything should be solved with CSS. Maybe some things should be rendered ahead of time. Maybe we should look into solutions how to do that natively into the browser, because a lot of the solutions that SAS provided are wonderful. And if you look at frameworks like Svelte, they can compute things ahead of time and give people warnings that things should be more accessible, or give people a warning that a selector is actually never used. And these kind of things really help you. And one thing that I feel like is missing in the dev experience of the current logic of, for example, custom properties, is that you cannot really accurately debug them. For example, a custom property, you can give it a fallback, right? You can say, okay, I want my color variable to be hot pink, and if the hot pink variable is not available, I will give it a color of red. So anytime I see the red, I know that that variable does not exist. In SAS terms, in SCSS terms, you would get a compiler, or you would be like, we cannot compile your style sheet because that error, it does not exist. So all in all, if you want to debug custom properties, you kind of have to awkwardly add fallback values. And with color, at least, it's quite obvious that something is rendered as a fallback value. But what if your fallback value, or whatever you're coding, is kind of like a clamp function with a min, with a max, with a preferred value? It's really hard to infer if whatever you're setting there is rendered as the default pixel value or the actual computed pixel value. So I think in a way we need better tooling for that. We kind of need a list of all selectors that are not being used for custom properties. We kind of need to learn from some of the tooling from the framework and make it a standard so that we can enjoy it and there will be less need for frameworks over time. I think there will always be a need for frameworks, but they can be a conversation. Frameworks can influence the standards, standards influence the frameworks. It is exactly like that. And I think we should be careful where we do which computation and make sure that in the end we have meaningful code that is maintainable and that over time is an elegant system that can provide a performant logic for the end users.